just tell you the way it works is whatever buttons the astronauts tell you to hit, those are the buttons you hit, and everything seems to work just fine. So anyway, it's been a great day today. Thank you to Elon Musk and your team for enabling all of this to happen. Know this, NASA has a lot under development right now. And there is a big difference between development and operations. We think back to Space Shuttle. That was an operational capability that existed for decades. And what we're doing now is we are developing brand new things that have never operated before. And Commercial Crew is one of those. And the Crew Dragon is an element of Commercial Crew. So is the Starliner, the SLS and the Orion space capsule, the Gateway, a human landing system that we will have under development shortly. But yesterday, as a matter of fact, I was out at the facility of Northrop Grumman looking at the James Webb Space Telescope, which again is an amazingly complex system that NASA has under development. We have right now a lot under development. But I will also tell you, and Elon and I are in strong agreement on this, that the one thing we have under development that is of the highest priority is launching American astronauts. We're going to have hardware delivered to the Cape, to the Kennedy Space Center. And of course, between now and then, there's a lot that needs to be done. We have a static fire that is going to be happening in short order. We have a high altitude abort test that will be happening in short order. And once all that data comes back, we've got to make sure that we are adequately meeting the margins necessary to make sure that these two gentlemen right here are safe. And Elon and I are in strong agreement that whatever it takes to make sure they are safe is what we are focused on like a laser. So I want to say thank you for being here. We are open to answering any questions here, but Elon, I'll turn it over to you for a few comments, and then we'll open it up for questions.
Sounds good. Well, it's an honor to be here with the with NASA Administrator and with Bob and Doug, who will be the first astronauts on the Crew Dragon. This is the launch of Crew is something that we've been working towards for 17 years. Actually, most of that time with NASA. We've now done actually 19 berthings and dockings or connections with the space station. So we've gone up to the space station 19 times in partnership with NASA. I think a lot of people don't realize that we've actually been there 19 times, including one of those times with the Crew Dragon design, and then the one that will be going to the station with the astronauts will be an improved version of the one that has already gone to the space station, docked and returned. This human spaceflight is the reason that SpaceX was created, and we're incredibly honored to partner with NASA and to make this happen. This is your dream come true, really. Whoops. Yeah.
We're open at any questions.
I have a mic over here.
Okay.
I ask that you keep your questions focused on today's topic, Commercial Crew Dragon.
Hi guys, Tim Dodd, the Everyday Astronaut. A couple questions for both Jim and Elon. Can you give me a rundown on why exactly both Commercial Crew vehicles have opted for
that? You don't have to discard the launch abort tower on every mission. So I do consider that like any significant state change after launch is a potential failure mode. So traditionally, if you had a solid rocket motor, especially if it's a tractor mounted on the nose, you would first of all be unable to, it's too heavy to carry all the way to orbit, so you would only have a partial abort capability. It doesn't take you all the way there in safety. And then because it's using the same propellant as the on-orbit maneuvering thrusters, you get dual use. Because you either need to abort or you need to do orbital maneuvering, but you don't need to do both. So I think it's a fundamentally improved design and a material improvement to improve safety.
And I would add that it is a fundamentally new design, and it's not easy. And over a year ago, when I, as the NASA administrator, when I first came here to Hawthorne as the administrator, of course I was here as a member of Congress before that, but as the NASA administrator, Elon and I sat down and we had a conversation about risk. And I asked him specifically, what is the biggest risk that we're dealing with here? And his thought was at the time that the concern was using the propulsion system for the launch abort system, which had never been done before. It's never been integrated in this way, and making that transition in pressures from a propulsion system to a launch. Elon Musk said to me, he said, that's the biggest concern. That's what we need to be worried about. And I will tell you, if we look at the catastrophic failure that happened back in April, he was right. And that gives me confidence. And that is why we test. And what we learned from that is going to make us all better in the future. And I can tell you that we have confidence based on that experience that what we have iterated since then is going to make us all safer. And it's really, again, about Bob and Doug. And Elon, and we were just in a meeting, Elon looked at them and he said, we are not going to do anything that these two gentlemen are not comfortable with. And that puts all of us in a great position. So to be clear, this is not easy. But to be clear, it will make us safer. And that's important.
Yeah, I think there's always like some expectation of the interaction between the orbital maneuvering system and the abort system. That's why we do the test. If you don't do tests if you think everything's going to be fine. You do tests if you think they might not be fine. And so that's why they're called tests. So you figure out what the issues are without any crew on board. You establish root cause, improve the design, and retest. And that's what we're doing. And one of the things, for example, that we're built liquid with a lot of pressure behind it and a long line, because it will essentially accelerate that small slug of liquid. It's like a bullet, and then if it has anything that is remotely combustible at the end of that line, it will like even light titanium on fire, which is what it did. So putting a burst disk in there isolates the abort system from the orbital maneuvering system and prevents any valve leakage that could get a small slug of liquid in there.
So today, when we first talked today, he said the Dragon is basically a bunch of valves.
It's a lot of valves.
Now there's a few less valves, which is good because it's going to prevent these kind of errors. I wouldn't have said that earlier, but since you just said it, we're okay saying it. So.
Having a burst disk there instead of a valve is better because the burst disk does not leak. I think that basically, I think, was somewhat the reason there wasn't a burst disk in the first place was it's somewhat vestigial because at one point we were going to use the Super Draco thrusters to land, and so you want a fully reusable system that can land, then you wouldn't want a burst disk because you have to replace the burst disk every flight, and you'd rather have a valve. But since we're no longer going to do propulsive landing with Dragon, it makes sense to put burst disk in there. There's a ton of other improvements that have been made as well. There's a super inside baseball. Oh, inside baseball.
Hey guys, it's Chris Davenport from the Washington Post. For Elon and Jim, Elon, you were talking about how the overwhelming amount of your resources are dedicated to Falcon and Dragon and to this program. How important was it then to have the administrator in to see that firsthand, not just charts and data, but to see the hardware, walk the floor, be in the simulator? And for Jim, how important was that for you to actually be hands-on that way?
Well, I'll tell you, for me, the biggest concern right now is we are getting close to launching American astronauts on American rockets for the first time since 2011. And of course, a lot of people see what happened back in April, and they have concerns. And of course, there have been a lot of concerns about parachutes as well. And where we are today, I think, is a very positive position. And when we walked not just the floor of this facility, but other facilities here on the campus, I got face-to-face time with the people who are making the necessary adjustments to ensure safety. And I got to see them, I got to shake their hand, I got to see the work that they have done, and all that is very positive. There is no doubt that in the last weeks, we have had a number of conversations on the phone about what needs to happen in order to meet the highest priority, which is launching American astronauts again. And some of those issues, we talk about the integration of the launch abort system with the propulsion system. Some of those issues are important, but the highest priority has been the parachutes. A lot of people don't focus on that, but that's where it's been. And Elon has told me, and he's showed me now, that that's where their priority is. They are putting as much resources and manpower as they can to getting those parachutes ready, so that ultimately we can have consistent, repeatable performance. We can have those tested, the Mark III parachutes, to give confidence to us that our astronauts are going to be safe. And I think seeing all that has been a big difference.
Yes, with we think the Mach 2 parachutes, I mean, we think those are safe, but the Mach 3 parachutes are possibly 10 times safer. And in fact, I think that the Mach 3 parachutes, in my opinion, is that they're the best parachutes ever, like by a lot. Like if you were to compare the margin of safety safety factor of the Mach 3 parachutes to say Apollo, this is twice the safety factor of Apollo. This is really a good design. And so we're really putting all of our energy behind the Mach 3 parachutes, working with Airborne, which is they're really good at parachutes. And I was just there actually on Saturday and Sundays, talking to the chief engineer and the program manager and the people sewing the parachutes, and so we're going just full tilt on the Mach 3 parachutes. And you know, people think parachutes they look easy, but they are definitely not easy. And for those that know the history of the Apollo program, it was actually one of the toughest things in the Apollo program were the parachutes. And it was actually one of the toughest morale problems, because they had so many engineers quit over the parachutes. It's funny to read that, you know, and then have the same experience basically. I mean, I don't think we've actually had, you know, many people quit over it, but it is say like this is a pretty arduous engineering job to get the parachutes right.
Hi, my name is Michael Sheets. I'm with CNBC. This question I'd like the astronauts to actually answer first. And when you saw that video of the Demo 1 anomaly, and when you saw what happened to the capsule and the explosion, what did that make you think and feel? And since then, what has given you the confidence to say, you know what, yes, we're still getting inside this capsule?
Yeah, it's a good question. It's disappointing. You know, you get questions from your family, you get questions from your friends. You know, what happened? You know, do you know what happened? That kind of thing. So, but, you know, the other part of it you have to keep in mind is this is test, evaluation, development, and it's part of the process. You know, I think this became public because there was a video that got online, right? And this happens a lot. I guarantee you it happens a lot. It'll happen next week maybe to somebody doing an airplane test or maybe a space vehicle test. These things happen. And while it's disappointing, it also can be a real gift to the final design because you can inform the final design. You find the problems that Elon talked about and you go, okay, we need to fix this, we need to redesign it. And the team mobilized incredibly, both on the NASA side and the SpaceX side, to come up with why did this happen? What can we do to fix it? How can we rebuild the capsule and make it safer for crews in the future? And that's exactly what they've done. And now we're kind of at the end stages, as Jim put it, of verifying and understanding that we do have the margins, that the redesign with the burst disc works, and it works the way we intend it to work.
So Doug and I had just been down at Kennedy a couple days prior to the actual event, and so my first thought was to that team, because you know we feel so integrated with that team that their failure is not their failure; it's our failure as a team as we kind of go forward. So my thoughts went out to Kiko and the rest of the guys down there in Florida who had been showing us the hardware that they were proud of and telling us how excited they were to pull off the next phase of the campaign of tests that eventually lead to Doug and I flying the first mission for SpaceX on the Demo 2 vehicle. And so I thought of that team. I sent them a text, and then we got down there as soon as we could. Once we were out of the way, from a cleanup perspective, it wasn't the best area to send folks in that weren't in the right, protective equipment, and that's not our skill set. We don't, when there's an issue like that, we keep our distance from it and let the professionals handle it. And so that's where I was that day when it happened. We got an immediate message from the team here. I think Lee Rosen shared that there had been an incident and kept us informed, and that was another key aspect of any of these failures as they go forward. Giving us insight and sharing that understanding as we go forward has been a part of what makes me so comfortable with this team kind of going forward. And I just really appreciate how much insight we've been able to have and how quickly we've been able to have it in each of these cases when something like this has come up.
I think it's important to emphasize, because I think a lot of the public just isn't aware of just like what happens with testing. Honestly, if there's a test program and nothing happens to that test program, I would say that test program is insufficiently rigorous. That's the reality. And it's important to remember that that same spacecraft went to the space station, docked, and returned. And if people had been on board that craft, they would have returned safely. So when you test, you're testing extreme conditions, you're testing off-nominal conditions, and you're trying to find extreme corner cases of where things go wrong. And to be totally frank, if there hasn't been some hardware that blew up on the test stand, I don't think you tested it hard enough. That's the reality. So, you've got to push the envelope, find out where the outer issues are, and then address all the corner cases.
I will tell you, one of the things that SpaceX is really good at doing, in fact, you could say maybe the best, is fly, test, fix, fly, test, fix, fly, test, fix. It's a very different approach than a lot of our other contractors. And it is a way to iteratively make development changes very fast, and in fact to fail fast. Fail fast and then fix. And some people see concerns in that. I will tell you that I think it's different than a lot of our other contractors, but I don't think it's worse. I don't think it's better. It's different, and it's unlike, quite frankly, what our other contractors do. And I like it. I like it being a part of the mix of our contract capability. That there is this iterative fly, test, fix mindset that SpaceX has, which is very different than trying to qualify every subcomponent and every component and every craft before it ever, hits a test stand. SpaceX is very good at moving quickly, and that's good for NASA. It pushes us. It's good.
Yeah, I think there's a fundamental principle of make sure you fail on the test stand so you do not fail in flight.
An astronaut who, of course, has flown with our gentleman here, he's an amazing individual. He is in the acting position, and he's doing great work. As of right now, I'm very confident that we can continue moving forward and not have any delays because of the opening in that position, because of the quality person and the quality engineer that Ken Bowersox is. I would also say that we are looking for all of the best talent that we could find to fill that role. And we will come to a point where we settle on a name, and we're not there yet. We opened the aperture very wide initially. We have started narrowing it down, but we are not ready to announce who that person is. But I will tell you that announcement is not months away, it's weeks away. And that's a day that we're all looking forward to.
Hi, Rod Pyle with Space.com. Just wondering if you could give us a little bit more of an update on specific milestones for the parachute tests.
Yeah, so here's the thing that we have to have with parachutes, because it's not easy to model. What we have to have is consistent, repeatable performance. We need a lot of drop tests. And of course, because of the conversations that we've had over the last weeks, we now know that we are committed as a team, SpaceX and NASA, committed as a team to the Mark III parachute, which is superior to the Mark II, although the Mark II, we could argue, is safe. The Mark III is even safer. And we need to get, with the Mark III now, consistent, repeatable performance. I will also say that given where we are and the resources that are being deployed on that particular effort, we talked even today that we could see as many as 10 drop tests between now and the end of the year. And how those drop tests go and how they match the Mark II deployment of chutes, we can look at how similar they are or how different they are, and we can make assessments based on similarity that we can actually use a lot of the drop tests that we have on Mark II, and we have a lot of data on Mark II, a lot of testing on Mark II. We could use the data from Mark II to help qualify the Mark III, as long as we see consistent, repeatable performance that matches that of Mark II. So the question is, as we go through this process, what we will find is how consistent it is with the Mark II, and if it is consistent, it'll give us confidence that we don't have to do as many drop tests. If it is not consistent, then we will have to do more. And so we're going to learn that in the coming weeks and months. And that's one of the reasons why when we go forward, it is true, we believe hardware can be delivered by the end of the year, but we also have to make sure that before we put any people on any spacecraft, that we have the consistent, repeatable performance, and we have all of the data where we can make sure that we are meeting the margins that we agreed to ahead of time. So I would say, depending on how the next 10 drop tests go, we will know how many more drop tests we will need. Did you want to add to that?
Yeah, absolutely. So we expect to start the. We've done a number of Mark III drop tests, but we're hopeful to have the first successful Mark III drop test within a week or two, and then there will be a steady cadence of tests thereafter. We certainly want to get I think at least something on the order of 10 successful tests in a row before launching astronauts. So that seems like where the behavior of the parachutes is consistent across 10 successful tests. That's, I think, a good sort of figure of merit. Our best guess, and it's important to emphasize this as a guess, is that these tests we should get to something like 10 tests before the end of the year. But we may not. This is just giving you what we believe. Sure. The biggest difference between the Mark II and the Mark III is going to much stronger lines in the parachute. So going from essentially nylon to Xylon. There's actually a thing called Xylon, which is very impressive. The strength of the lines is about 3 times that of nylon, perhaps arguably more. And then there are some changes to the stitching pattern, so that because there are certain places where the load concentrates, basically where it's fairly obvious where the lines connect to the canopy, you've got a stress concentration, and so you want to have just exactly the right joint to spread the load at the stress concentration where the lines meet the canopy.
It is also true when we talk about parachutes, and this is important. We have learned a lot because of the work of SpaceX and because of the work of Orion and Starliner. We have learned a lot recently about asymmetry issues on the risers of a parachute. That being said, we can apply that as an agency. NASA can take that data and that information that we get from our great partners, and we can apply it across the agency as a whole to make sure that our astronauts will be safe. And so this is an area where it's not either or, it's all of the above. And when one partner is successful, that success is applicable to all the partners, because human safety is the number one priority for NASA and for SpaceX.
Yeah, I've been very, very clear with Jim that any SpaceX data should not be considered proprietary, and it can be used by any of our competitors no charge, for free, obviously. And
that will be very helpful.
Does anybody have another question for the astronauts who have to leave?
Hi, CBS News. Thank you, gentlemen. what will you be doing between now and when you launch?
We'll be here. Short answer, but we spend almost all of every week here now. And obviously with the in-flight abort, there'll be some crew-related timeline exercises we want to do along the line of the in-flight abort timeline. So when we do the in-flight abort, we'll be down in Florida for that. We may get down for the static fire, but the majority of our time will be here, training, running the sims with the teams, not only here in Hawthorne, but the team back in Houston. So a lot of time in California. And thank you guys.
They have to catch a plane, so we'll say so long. Okay. Thank you, guys.
Hi, Samantha Mastanaga, LA Times. Okay. I'm
There
right
you
here.
are.
I need that. I know you said that the program is close to human launches, but obviously it's also getting close to the end of U.S. availability of seats on Soyuz. Can you talk a little bit about that, Administrator? Is that a concern of yours at all?
It is. So clearly there's a number of things at play here. Number one is making sure that we get the hardware delivered. And I think we've got a good plan for how we're going to make that happen. And I want to also be clear, because I know a lot of the SpaceX workforce is going to see and hear this media. We are very grateful for their hard work, and we want them to keep pressing to make sure that we get that hardware delivered. While that is underway, we also have a number of tests. We have a static fire for the launch abort system, and then we have a high altitude abort test that we have to get done between now and the end of the year. And we will take all of the data from those tests and make sure that we are adequately meeting the margin and we are controlling those margins consistently and repeatably. And when that is complete, then we will be ready to launch. So what we have to do as an agency is we have to make sure that we're taking the data and making data-informed decisions to be ready to launch. Hardware delivery is not the end state. It is the beginning. And we have to take the data from the testing that we do between now and hardware delivery and qualify these articles for human spaceflight. And so I don't want to say what the date is, but I will say the partnership that we have with Russia is important and it's good. When we have these terrestrial challenges that everybody is aware of, somehow we have been able to keep space exploration separate from the geopolitics of the times. And that's good. And so we like this partnership. But we also want it to be a partnership. We don't want to have to pay $85 million every time we launch an American astronaut on a Soyuz rocket. We don't want to do that anymore. We would rather have it be a true partnership where we launch on their rockets and they launch on our rockets. That would be a great partnership for the future. And so we need to make sure that we do not have a day where we don't have American astronauts on the International Space Station. So we will be continuing to work with Roscosmos, which is the space agency of Russia, to ensure that we do have American astronauts on the International Space Station. As an insurance policy, for sure, because there's still some learning left to do between now and launching crew. To be clear, if everything goes according to plan, we may not need additional Soyuz seats. But here's what else we know. Here's something else we know. Usually things don't go according to plan when it comes to these new development capabilities. I will say that we're getting very close. And we're very confident that in the first part of next year, we will be ready to launch American astronauts on American rockets.
Yeah, I think it's like, we could just give you some insights into some of the best guess timing ahead. This is just best guess. So, what tends to happen with these things, you give the best guess, and then you get some article like, oh, they didn't meet the deadline. We're like, no, it's just a best guess. Like, if it was, sort of like, if this was a fully completed development, then you could say with precision, or with more precision, what the timing of things would be. But anything with that is in development, albeit even the late stages of development, you never know when there might be some thing that crops up that requires more investigation. We're going to look into it more closely. the tests I mentioned with respect to the Mach 3 parachute may take longer than expected. We may encounter things that we don't yet know, and that may require more testing. There's also the retest of the propulsion system and the propulsion lines to confirm that the design changes that we made will be successful in preventing what caused the test stand failure earlier this year. So those tests will happen probably in the next few weeks, and that will obviously be, if those tests go well, will be a significant risk reduction. I think it's like my philosophy is like to generally say what we think our best guess is, and then kind of bring people along for the ride, and say like, if things don't go quite as well as expected, hopefully you cheer us on, and like, but it's full disclosure. It's just telling you what we know as best we know it, and sometimes we'll be wrong. But I think it's more interesting to be along for the ride and not try to pretend everything is super great. There's always issues. Space is hard, obviously. It's like very few countries have gone to orbit. Created an orbital vehicle. Well, I guess really just 3. So this is a very hard thing, and so this is. So like, I hope, like, as we go along, there's a lot of people working super hard at SpaceX and NASA, and our suppliers just doing their best, and so, so those support will be good. So there's, so in the next few weeks, hopefully testing the propulsion system to confirm that changes made were successful. But, it's a test, so it could go wrong, could go right. We'll be doing a lot of tests of the Mach 3 parachutes. We'll keep the public informed, so you'll know what goes wrong and what goes right, and then what we're doing about it. Those are the only 2 items that I'm aware of, or that SpaceX is aware of, that put the schedule at risk. But there may be other things that we discover. This is also important to bear in mind. You do not know what you do not know, to the best of our knowledge right now, testing will be complete and hardware will be at the Cape by the end of December. But this may be wrong. Important. This could be wrong. This is what appears to be the case right now. So then there's some period of time after that, as the administrator was alluding to, where SpaceX and NASA and may be worse than the disease or comparable. Then it's not worth breaking configuration unless the cure is very obviously better than the disease. This is the only thing. I'm just telling you exactly what I think, basically. But I do want to emphasize this is not like sometimes this is like, is this, if the testing is complete and the hardware is at the Cape, is this like some kind of like massive bureaucracy that's delaying things? Like it is not. It is very important for everyone involved to go through all the data and then look at it again and look at it again and just confirm, like, have we done everything possible to ensure that the astronauts will be safe? This is a lot of homework, basically. And then only at that point would we launch. Only at that point. But I think it'll be very exciting to see the hardware at the Cape, and very exciting to see these tests complete. And we'll make sure you're kept up to speed on all of the, everything we learn, good or bad. So you'll know the straight's good.
Hi, I think you may have answered my question partially, but I just wanted to put it to you a little more directly, Administrator Bridenstine. Given everything that still needs to happen before the crew can actually be delivered, what is your how soon do you think that you will be ready to launch a manned mission with the Crew Dragon? I mean, I think you said like maybe as soon as early part of next year. Is that what you said?
If everything goes according to plan, it would be in the first quarter of next year. But remember, and this is the important thing that we have to get right on messaging, there are still things that we can learn or could learn that could be challenging that we have to resolve. I'm not saying that's going to happen. I don't know. That's why we test. We have 2 very important tests coming up, plus a whole lot of drop tests for parachutes. Depending on what we learn in those tests will determine whether or not we're going to be able to launch in the first part of next year. But if we learn what we think we're going to learn, we should be ready in the first part of next year. If something comes up that we didn't know, then it could be longer than that. But this is what Elon was talking about, which I think he said very well. Regardless of whether we make it in the first part of next year is less relevant than the fact that we will make it. And when we do make it, between now and then, we need your support. And I think that's pretty clear what Elon was getting at. This is a big deal for our country. We can't get it wrong, and in fact, we have to get it right. And so I think these are key messages that we believe it can be done in the first quarter of next year, but we are not going to take any undue risk because the safety of our astronauts and the success of the mission is the highest priority. And remember, this first flight with crew is a test flight. Even the flight itself is a test flight, and it is done with test pilots, 1 Marine.
We will start building the next one, and we expect to be making Dragon version 2 or Crew Dragon on approximately every 3 or 4 months. So there'll be a number of the craft that are in work. So, 3 or 4 months' time, there'll be another Dragon that's also ready to go, because we want to get into a cadence, as Jim was saying, of operational flights to the space station. I think it's been 8 years since the United States was able to send astronauts to orbit. This is travesty. To tell you frank, we need to get back to.
But it's going to be a great day.
It's going to be a great day, yes. But we've got to get this done, So it's a super big deal. And then we'll get into a cadence of regular launches next year. Yeah, it'll be great.
We have a question from NASA Watch, Keith Cowie. He writes, "You are both Star Wars fans. Elon builds X-Wing fighters and Jim flies them. Instead of the differences we've been hearing about recently, what things do SpaceX and NASA and you as individuals share in common when it comes to the future uses of space, and how will you leverage these common interests?"
So you build X-Wing fighters, and I fly them. That's cool. That's great. I like that. I'm liking this already. A couple of things. Number one, there's no need for wings in space, so I think that's a difference.
Yes, that is true.
And if you look at how the X-Wing fighter is thrusted, I'm guessing, I don't know, but I'm guessing it might be nuclear electric propulsion based on the design of the vehicle. But again, I don't know how the X-Wing is designed. But I will tell you that we as an agency, we want to go to Mars and even beyond. And of course, we're very excited about the excitement that Elon is bringing to this, that SpaceX is bringing to this idea of humans expanding throughout the solar system. That is something that I think both of us share deeply as a vision that we want to be able to achieve. And I think that is achievable. Now, going back to the X-Wing fighter, in order to achieve that for the long term and be successful, we're going to need to start making investments in nuclear thermal propulsion and nuclear electric. And of course, we've been involved in the Vassamir propulsion system as a development capability for a number of years, which is nuclear electric. The idea being that we need to get places faster. And NASA has an interest in that. But I think more than anything, NASA has a keen interest in human exploration. Elon Musk and SpaceX, they've done
So, yeah, it's just something that people here around the world can get super fired up about and get excited about the future. And future where we're a spacefaring civilization and out there among the stars is inspiring to people everywhere in the world.
Hi, Ted Chen from KNBC. Back to the topic of timeline and delivery. Can you both address the recent public exchange regarding the progress of Crew Dragon, in particular, Mr. Bridenstine, your tweet implying that progress was being compromised somehow by spaceship?
Yeah, so as the NASA administrator, I have been focused on returning to realism when it comes to cost and schedule. And a lot of our programs have not been meeting cost and schedule. And this has been developing over time. And a lot of these programs are, 5 years old, 10 years old, that kind of thing. And so what we're trying to do is get back to a day where we have realistic cost and schedule. And so I was signaling, and I haven't done it just to SpaceX, but to all of our contractors, that we need more realism built into the development timelines. To be clear, the development timelines are development timelines. This is not operational yet. It is development, which has put us in a position, and it's not just the Commercial Crew program, it's a lot of NASA's programs. And I am trying to make sure that if we're putting out key messages about what we're capable of achieving, that we are matching it with budgets. That's been a high priority of mine. I just want to make sure that we are focused on the number one highest priority for our country right now, because I'm the one that has to go make sure that we're buying seats, Russian Soyuz seats, to keep a presence on the International Space Station. A couple of weeks ago, I was out at Japan. We believe that there is a strong probability that they will have an astronaut on the International Space Station during the Olympics. But there is also a possibility, if things don't go according to plan, that they will not. That's a challenge for me as the NASA administrator, as I try to encourage our international partners to invest more than they ever have before in our effort to get to the moon sustainably. In other words, we want to go to the moon to stay. So in order to achieve the diplomatic goals and the strategic goals of our country, to have our international partners with us in a coalition of nations to go to the moon to stay, in order to achieve that, we have to have credibility in our programs. And right now, the one program that we need the most credibility in the fastest is the Commercial Crew program. And SpaceX is a big part of that. So I think those are all important takeaways.
I mean, it is important to, these are just historical facts. It's not just a statement of fact. The SpaceX Commercial Crew program is within 1% of the budget. So it's right on budget. As Jim was alluding to, the NASA request for Commercial Crew for several years was substantially reduced by Congress. I think in some cases by 50%. So it's pretty hard to stay on schedule if you've got half as much money. But we didn't spend more money. It just took longer. The same years that Commercial Crew was dramatically underfunded, some other unmentioned programs were overfunded. So anyway, the larger point is we're going to get this done, and we're going to get done soon, and we're going to get done right.
Hi, Grant Blaisdell, co-creator of Copernic Space. This is a question that alludes to two things that both of you touched. There's going to be a lot of sensitive and valuable IP being shared between you guys, but also in the future collaborations. You brought up Russia, for example. And we've seen NASA recently begin engaging with new tech, like blockchain technology, seemingly mainly to improve data-related trust and security. Mr. Musk, I know you're interested in this tech as well. My question is NASA and this collaboration further looking to use this sort of tech to not only securely transfer and collaborate around this valuable IP, but also to use it to better commercialize this IP on the private market as the market continues to digitize and privatize, especially for NASA. I think that would be cool. And also funding. How this relates to allowing the American public fund NASA
do that, it is for a reason. It is because we have to make sure that we are safely flying people, because there is nothing more precious to us than the cargo which is our astronauts. So that has to be, I think, a keen awareness for us. If SpaceX learns something with parachutes, if they learn something with a launch abort system, if it's a materials issue, we need to be able to share that. And SpaceX has been fantastic about allowing us to do that without giving up, design specifications.
Actually, I want to be clear. NASA can share all of our IP with anyone that NASA wants. There you go. You can have it all.
We'll
and
take
share
it
it with anyone.
But to the extent, ultimately, and we appreciate that.
Welcome.
That's very meaningful.
Yeah.
But there is IP that is in the interest of the nation that we cannot be sharing with people or countries that would not have our interests at heart. And that's when it comes to making sure that we have our information technology secure and we have all the capabilities necessary to protect some very valuable technology.
Thank you. We have time for one more question. And
Just a quick follow-up, because you had mentioned that you had spent near...
Informed by the NASA program manager, yeah, you're working 1%. I'm like, great, that's cool. We have spent, actually, I'd say quite a lot more than expected. Probably on the order of hundreds of millions of dollars more. Yeah.
So for the contracts, I mean, it's based on milestone payments, and when milestones are achieved, payments are made. And of course, our contractors make proposals, and then we award based on those proposals. And so all of that was agreed to up front. It is absolutely true that there were certain years early on that set us back because we weren't adequately funded. We're past that. We are now focused like a laser on the right things to achieve the end state that we both desire, which is American astronauts launching on American rockets. I know this is the last question, and I just want to say a few more things in closing, and that is this. I want people to make no mistake that NASA has an interest in seeing Starship be successful. We have been a partner on Starship, a non-exchange of funds kind of partner, when it comes to aerodynamics and when it comes to testing and test facilities. Certainly when it comes to how we do, think about the future where maybe the Starship will be flying in deep space outside of Earth's orbit. And if that day comes, they're going to have to communicate back to Earth. So we have been working with SpaceX to enable and test deep space communication capability using NASA's deep space network. We in fact are using our resources at Mars right now. We have orbiters around Mars. We have a lander. We have a rover on Mars. We task those resources to find where would be the best places should Starship be successful in going to Mars. Where would be the best places to go where they would have resources, in situ resource utilization available to them. That's another capability that NASA has been working to support SpaceX on Starship. And just this week, might have been last week, I don't know the date specifically, but we did award to SpaceX a contract, what we call a tipping point contract, it will enable Starship to use NASA resources and NASA money to figure out how to transfer fuel in orbit. That's a capability that is in the national interest of the nation, but it's also a capability that enables NASA to go further. And we want partners that are willing and able to invest in that to partner with us, which is what Tipping Point is all about. And they were awarded a contract for that. We believe there is a day coming, whether it's to be clear, we want commercial crew to happen at the earliest possible point. Make no mistake, I hope I've been very clear on that. But we also want all of our commercial partners, to be successful in going further and doing more under an idea where NASA would be one customer of many customers, driving down our costs and increasing our access. One customer of many customers with numerous providers that are competing on cost and innovation. Again, driving down cost and increasing access so that all of us as a nation can do more. And some of our partners are Starship, as I just talked about. Some of our partners are SLS and Orion. And all of us as a nation, we will be able to do more, and they make each other better. And that's a positive thing. But we want all of our partners to be successful, and we are working towards that every day.
All right, thank you for the support. This is, yeah, for sure, Dragon and Crew Dragon is absolutely the overwhelming priority. You know, as I've said publicly, is maybe 5% of SpaceX resources on Starship. We do think it's something that will be incredibly valuable to NASA in the future, and to and really anyone who wants to. I think we think it will be very important for the future of humanity in space. This is so, we are transitioning into a phase, or very close to transitioning to a phase where we are in series production with the Crew Dragon spacecraft, which means that the engineering team can then work on a new vehicle. You have design and development, and then you transition design and development to production and operations. But then the design and development team should do something new. This is not a conflict; it's just different teams, and that's what we'll be doing as we complete the testing of Crew Dragon. Is transitioning the development team to Starship. So thanks again for your support.
It's an honor. Thank you for having us. And I want to say to all the media here covering this, thank you. We need to create an environment, and SpaceX has been amazing at it. Create an environment where the American public, and in fact the world, gets enthusiastic about returning to deep space. I am the first NASA administrator in history, well, at least since we've gone to the moon. I'm the first NASA administrator that doesn't have a memory of where he was or she was when we landed on the moon, because I wasn't alive yet.
Yeah, me neither.
Yeah, right.
Yeah.
And I'm 44 years old. We cannot allow another generation to go by without people like us casting a vision that we can, in fact, have a sustainable presence on the moon,
yes,
that we can, in fact, get to Mars.
Yeah, absolutely.
And because of the media here and all of your coverage of this and other events that we're going to be doing in the future, we're going to be able to do this. And I just want to thank you for having me at this event, and look forward to, again, launching American astronauts on American rockets from American soil. So thank you, SpaceX, for being a great partner.
Thank you. All right.